All right, friends, just in case you haven't seen my face enough when we are talking about factoring, we are now talking about special cases. I love these. I love these. I was helping a kid study for the SAT, and you would not believe the number of times that these come up on the SATs, PSATs, that kind of thing. So I want you to really make sure that you understand these special cases. Grab your notebook, write these down. Okay. We've got two different types here. We have difference of squares, perfect square, trinomial. Pause the video, write those down, and then these will make sense. Here's how it works. We are going to do some difference of squares. Difference of squares. Now, difference of squares means you have a perfect square minus another perfect square. Here, I have a perfect square minus a perfect square. If I needed to, I could rewrite it as x squared minus 3 squared, because that is what 9 is, 3 squared, right? This factors to be x plus 3, x minus 3, just like that. Again, I have another perfect square here. I have x squared minus 4 squared, because 4 squared gives us 16, which means this garbage right here factors to be x plus 4, x minus 4. Now you can put the plus or the minus in front. Doesn't have to be in any specific order because we're multiplying, but you do have to just do it like that. Now, why? You may be asking why. Here's the deal. I want to show you if I have x plus 9, x minus 9, like this. Let's say I use my FOIL method, or let me use the distribution method to multiply this out. So I'm going to take x and multiply it by these two things. So x times x minus 9 plus 9 times x minus 9. I'm going to get x squared minus 9x plus 9x minus 81. I just distributed here, here, and then here and here. Okay, negative 9x, positive 9x, kablam. Those cancel out and I get x squared minus 81. Now you may be asking yourself, what if it looks like this? X minus 9 squared. That is obviously x squared minus 81. Absolutely, it is not. Because I just showed you they have to be different, not the same. We're going to get more into that, but I want you to see the difference between these two. So if you take this and you FOIL it out, you end up getting rid of that middle term. All right, so let's move on to another one. We've got x squared plus 49. Can I factor this? Absolutely not. I cannot. This is called difference of squares, and in math, difference means subtraction. I cannot do that. This is addition, not subtraction. No, you cannot factor that, guy, so be careful with that one. Here I have, again, a perfect square minus another perfect square. If you do not know your perfect squares up to 15, I would highly recommend that you do that. Okay, so in this case, what we have is x plus 11, x minus 11, and bam, you have just factored that out. Let me just tell you, perfect difference of squares are hidden everywhere in factoring. So you want to be able to identify as soon as you see a perfect square minus another perfect square, identify that and be like, zero in difference of squares plus minus, okay? So reminder here, x minus 9 squared, the whole quantity x minus 9 squared, is not just x squared minus 9 squared. No, no, no. You have to write it out like this. And notice as soon as I write it out like this, that kind of triggers something. Hey, I either have to do FOIL, box method, distribution in order to multiply that out. If I were to do that, I would end up with x squared minus 9x minus 9x plus 81. That combined like terms, I get x squared minus 9x is minus 18x plus 81. Kablam. This, remember back here, you were like, oh, let's just do x squared minus 9 squared, which would be x squared minus 81. No, 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 it's not. It's this. But the neat thing is, this is called a perfect square trinomial. It is a binomial that is squared. So it's a binomial times the exact same binomial. There's a pattern there. I don't expect you to memorize this pattern quite yet, but it will come in handy in Algebra 2. So I do want you to be able to identify it. So let's talk about what that pattern looks like. Okay, worst case scenario, you see this and you're like, okay, so I have x plus 4 squared. That's x squared plus 16. No, I want you to hear my voice in your head saying, absolutely not. What I want you to do is instead write x plus 4 times x plus 4 and then FOIL that out. That's the best, that's what you can do. Now, there is a pattern, and here's how that pattern works. It goes like this. You take the first thing and you square it. Then you bring down this sign. Then you take these two things and multiply them together. 4 times x is 4x. Double it, you get 8x. And then you take always a plus at the end, and 4 squared is 16. There you go. You have just multiplied that out. If you see, we'll do x plus 4 times x plus 4. And if we use the FOIL method, we would get x squared plus 4x plus 16. That's x squared plus 8x plus 16. And you see that's what we got. But I didn't make you FOIL it all the way because I'm a mathematician and I am lazy, and mathematicians are lazy. Don't quote me on that. But I like to find the easiest way to do things. Okay, so what we've got here then is this guy. So this one, same idea. We're going to say x squared, bring down the sign, minus. Now we multiply those two things together. 7 times x is 7x, double it, you get 14x. Always plus at the end. 7 squared is 49. And there you go. You've just multiplied this all the way out. Now, if you can't remember the pattern, that's fine. But what you're going to do is you're going to cross that out and you're going to say x minus 7. And you're going to FOIL that bad boy so you don't make a mistake of saying, oh, it's just x squared minus 49. Now, why is this helpful? It's also helpful in reverse because now we can make factoring a little bit easier. Instead of listing all of our factors for 144, I can't even talk. I look at this and I see perfect square in the front, perfect square in the back. I wonder if this is a perfect square trinomial. And what I'm going to do is say x. You always use the first sign, minus. That is a perfect square. That's 12 squared. Now, let's test to see if this is a perfect square trinomial. Remember, for the middle term, we multiply these two things together, so we get 12x. Double it, we get 24x. Kablam, you've just factored this without having to list all of your factors of 141. Same with this one. I see a perfect square in the front, a perfect square in the back, and I get x. Oh, that's not an x, that's an m. M, and then I use this sign, so plus, and then 3, and I square it. Now I'm going to do a test. M times 3 is 3m. Double it, you get 6m. Yes, I just factored this. That is called a perfect square trinomial, and the difference of squares. Don't lose track of those things because they do come up again and again. All right, we'll see you next time.